Let us master the skills and beat the competition. The question before us has two parts. We need to find the HCF of 65 and 117, and then if this HCF is equal to 65A plus 117B, find a pair of integer values A and B. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. So let us find what is the HCF of 65 and 117. So to find the HCF, we are going to use the Euclid division method. So we need to find the HCF of 65 and 117. So it's a repeated division process where remainder is involved to divide the quotient. So 65 being a smaller number, it becomes the divisor first, and we are going to divide 117. 65 goes one time in 117. What remains is 52. Dividing 65 now by 52, we get 1 as the times, and then 52 gives us a remainder of 13. So now with this remainder, we will divide 52, the divisor. 52 goes 4 times with 13, remainder being 0. So that gives us the HCF of 65 and 117 by this process of Euclid division. You can actually follow up on our playlist to practice with more examples. There are many methods of finding HCF. This is one of the best ways of doing it. So now our equation becomes 13, which is the HCF, is equal to 65A plus 117B. A and B are two integer values, right? So we can try some values of A. So if, let us say, A is equal to 2, then we get 13 equals to 65 into 2 plus 117B. Now, from here, we can say 13 minus 65 times 2. Let me open and bring it on this side. So 10 and 1, 13, right? 12 times 1 is equal to 117B, right? And that is equal to minus 117, right? So it is 117B. And from here, we get the value of B as equal to minus 1. So at this stage, since there are two unknowns, A and B, and we know that both are integers, we need to try some values out and see for what value of A do we get a integer value of B. And so we get a combination, and this solution now is, as you can see, A is 2 and B is minus 1. So that is a pair of integer values, A and B, which provides us the solution of this particular problem. So I hope the steps are absolutely clear. Here is another example where we will practice the method of finding HCF between two big numbers. We'll understand the process of finding HCF, the highest common factor between two numbers. When these numbers are large, it is very important to use Euclid division algorithm or Euclid division lemma to find the HCF. I'll show you two different ways of doing it. Follow the method which you like most. I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Here are two numbers 351 and 459. Let us see how do we find the HCF between these two numbers. So Euclid division is a repeated process where the remainder and the quotient divide into one another constantly. So now let's try to understand the process of Euclid division. Two numbers are 351 and 459. We'll divide the bigger number, which is 459, by the smaller number 351. It goes one side and the remainder is, so when you take away, 9 take away 1 is 8. Here we get 0, 108. Now, with this remainder 108, we are going to divide 351. You get the idea. So that is how this division is slightly different, and we go like a long division process. So it can be divided 3 times. So 3 times 8 is 24, and 3 times 1 is 3. Now the remainder is 11 take away 4, which is 7, 4 take away 2, which is 2. And with 27, we are now going to divide 108. 108, we can divide this clearly by 4. 4 times 7 is 28, 8 and 2, 4 times 2 is 8, and then finally we get a remainder of 0. As we see that 27 divides into this number completely, correct? So we say that 27 is HCF of these two numbers 351 and 459. Now that is one way of dividing. The other, which is kind of a division statement, can also be shown. So here's the second process. I hope the first one is clear, right? So we can actually write 459 as equal to 351 times 1 plus the remainder, right? So when you take away 351 from 459, you get what? You get 8 and 5 0, and this is 108. So 108 becomes the remainder with which we are going to now see how 351 can be written. So 351 can be 108 times something, which is times 3 plus what? What is the remainder in this case? So that is 324, and 324, when you take away from here, you get 27. And clearly, we can now write 108 equals to 27 times 4, the remainder being 0. And therefore, we can say that 27 is the HCF. Perfect. This is slightly more difficult as there is a lot of calculation which you have to do. However, this process of long division, which I showed you first, is straightforward. So you could use any of these two methods to find the HCF or these two numbers. Let us also understand the significance of HCF, right? Now, 27, which is the HCF, can always be written as in a division statement because this is a common factor between the two, right? So you could always write 27 as equal to something like say 351 times A plus 459 times B. Now, since it can be written like this, it is the common factor of each. You have to find the value of A and B. You can say one set of values of A and B. That could be a test question, okay? Well, in the video, you have understood How do we find the HCF? There are two different processes. One of them is the long division, the other is the division statement. You could use either one of them to get your answer. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.